Turbine Design, presented by Gerald Brown, Robin, Malia Waddell, and Connie Wells. On today's agenda, we'll give a brief introduction, problem statement, methodology, design, a brief discussion, and answer any questions you have about our wind turbine design.
Problem statement. Wind turbines face problems such as their inefficiency and cost. The group works on improving the output of the turbine to help balance and justify the costs associated and potentially expand the life of the device by selecting more optimal gears.
The methodology. So the group did research on the average lifespan of the wind turbine gearbox system and what would cause the gearbox system to fail. About 37% of gearboxes fail in the first 7 years of usage. Common failures include gears or bearings being too small, bearings fitting loose to the system.
Design specifications.
We used are from Shigley's Mechanical Engineering Design Book, 10th edition. We followed their steps 1 through 10 to check for our desired gear ratio, how many teeth each successive gear would need, and we also had to test to make sure that there wasn't any interference. For every stage of the calculations, we had to test for the gear ratio, so everything from the planet gears to the third stage, which is technically the second one in parallel. We had to run all of those equations and then make sure that our desired number of teeth was in 1% of our desired ratio, as well as they were all larger or equivalent to the smallest one that we found to eliminate interference. For results, we did 109-to-1 ratio, which was the one that currently exists in our 3 megawatt turbine that we based everything off of. We did 120, 140, and 90 to see what would happen if we went down. We used 100 RPM as the base input for all of them so we could get fairly consistent results. Based off our calculations, the gear ratio of 140-to-1 was the most optimal regarding energy transmission, because it obtained the highest output revolutions.
Increasing gear teeth amount increases the output RPM, but also comes with its own associated concerns. An increased number of teeth will result in either smaller teeth that need to be machined or increase in the overall diameter of the gearbox. There is still the size constraint of the actual gearbox itself, so these factors must be considered when looking for the best design. If the group can improve output, overall quality, and simplicity in the gearbox, the effects could be a longer lifespan of the gearbox, which will then be more economically feasible because there will be less repairs or gearbox replacements that could lead to downtime of the turbine. The societal impact that this proposed technology will have with the increased output ratio are the increased renewable energy production, which will allow for more electricity to be provided to the consumer. The production of making these gearbox could also add jobs, which would increase employment, and this would benefit the economy. In 2017, the wind turbine industry provided about 101,000 jobs to the market. Sound pollution is one of the environmental impacts that can occur with the increased output revolutions. Humans can be bothered by the humming that results from the spinning blade and the internal workings. Animals also can be put under greater distress and be displaced due to increased noise in the environment messing with their senses.